So, good morning to everybody. I started the recording, so everything is fine. Now, if you remember, we started yesterday to see what is a possible classification of production systems. For those of you that follow the course at the bachelor, this is to some extent an overlap, is to some extent new. And when we are going to design, to see the technique for designing each of these production systems, we will review more in depth the characteristics, the advantages or disadvantages of those kind of production systems again and again. But this is to some extent new, because without that one, we cannot understand why we're going to apply that method for another one. Okay, so last time we said that three main classification axes. One related with how the product is made, one related with how the production is managed, okay, and the third one, how the demand, how you fulfill the demand with respect to market and the client. As I told you yesterday, those three dimensions maybe are the most characterizing axis that we can choose, because you have here the idea of which kind of process you have inside, how you use them, and how you interact with clients. This is the reason why this is maybe the best classification scheme that we can find. If you remember, last time we start considering, okay, the classification by the nature of the process, and introduce the differences between process production and discrete production, also referred as manufacturing, even if manufacturing is to some extent a little bit has been in the last year more ambiguous in the meaning. Within discrete manufacturing, we will find both fabrication and assembly. What is the idea of process production? Let's make a reference with products. So we're referring to the production of basic material like cement, like gas, like plastics, okay? So they are creating from raw material, starting material for every kind of industries. Every kind of industries, as usually we know, because this all kind of industry stays in discrete manufacturing. Okay, why this one? Because when we start with oil and we transform it into plastics, we start from ore and we transform into steel. In the end, I think none of us have never, get in touch with a steel bar as a final product. But many of you have seen how this bar is transformed through discrete manufacturing into desk, into cars, into bags, into every kind of things. Okay. This is also the reason why process industry is usually seen as a supplier of discrete production industry. Okay, and following this way of this logic flow, the idea is that normally when you produce a steel bar, this is passed in the discrete production industry, and usually from this bar, components are created, are fabricated. Please make reference to material removal. That is maybe the most adoptive family of technologies. So that you have the steel bar and you transform them into a component. Whatever you want, but last time we make reference with a camshaft or a crankshaft. Okay, that is one of the components of the ING, internal combustion engine. For this one, all the components are fabricated and then pass to the next kind of discrete production, that is assembly. All the components fabricated, so the camshaft together with the head, the basement, okay, with all the components are joined together, put together in the assembly process. Okay, so this to some extent, maybe, okay, we can swap this if you use, but this is the idea of how these different production come together and follow each other. Last time also we focus on the characteristic of process production, okay? And we say that usually this kind of process production, you have one plant for one product, one or a limited number of products, okay? So that if you make reference with a refinery, you have one raw material into, and maybe you can have different, let's say, products, gasoline, kerosene, whatever, but in the end, in a very small range of output, okay? You have cement, so we say last time, kaolin, whatever, all the order coming into, and in the end, you have cement. Maybe you have different variation of cement. In the end, it's cement. If you go with glass, it's the same, okay? This is the idea. What is the other characteristic of those kind of process production? Is that the technology route is completely fixed. So the one operation follows the other, and we cannot swap or change or to some extent leave one of them. We have to follow them in a perfect way. Not only, the idea is that if we need to warm or heat, okay, some of these ingredients, say, of the glass or the cement, we have to use that specific temperature, that specific speed of the flow. So everything is completely planned. If we change operations, if we change parameters of the technology, we are not going to obtain the final product. This is also the reason why usually the technology route of the process usually is patented, has been developed by scientists, by chemical engineer, whatever, and they patented because it's the only way of obtaining. If we look at the glass, okay, Pinkerton, one of the first person that developed a way of have flat glass. Today, in every part of the world, you can design plant. You are going to buy and to pay royalties for using their patents. No way. Maybe I follow construction of a glass plant in Egypt recently, and the idea they are using 141 Pinkerton patents. Okay, because there is no other way. So the point they study a lot, make a lot of experience, and so you have to transfer that in your plant. So usually you also take advantage also from the experience and expertise of Pinkerton engineers that come into and help you implement, okay, the technologies. Okay. The other characteristic of this kind of plants, okay, is that they can be, as everything is fixed. You can see this plant that is composed of pumps, pipes, a lot of vessels, whatever, in the end. But in the end, is controlled as a unique machinery, in the end. If you think at a lathe is composed of different components. You work with that. It's a black box in the end with respect to the input and the output. This is a big black box in the end. You start at the bottom, everything is controlled centrally, and everything must work, otherwise everything is stopped. It's a big machine. Why we can see this as a big machinery? Because if everything should be done in the same way, we have only to start it and to stop it. every other change in the pace production, change in production rate or stopping production rate is a big issue, is the big issue of such things. So they, in order to be efficient, they have to keep on working 24-hour days and close to 360 days per year. They stop only, and this is planned years before, for major maintenance intervention. In case we need to change a vessel, we need to change some pumping system, we have to change a section of the plant. If some problem issues happens in the between, so some failure happens, is a little disaster in the end. Okay. Here we do not need many operators. In the end, there are no operators, but in the plant itself, not at the boundaries. Okay, but supervisor. This is only one machine that had to control all the process parameters. So this is also the reason why the cost of labor as a whole is limited with respect to the cost of the plant, but the wages of the single operator is quite high. Also, but this is very similar to every kind of machinery, usually when you restart the plant, it takes time to have good quality output. If you look at plastics, and we have a case on this in the future lessons about this one, maybe it takes 1 day, 2 days of scrap production before you can have production that can be sold in the market. Because the idea is that the process need to warm up to some extent before you have, let's say, perfect or a product that is compliant with the request of the market. All this kind of industry use plenty of energy. Okay, this is and usually they process high quantities, so they usually are huge. This is also the reason why the location of this process plant usually is the major decision about the plant, where I have to locate it. And if you look at steel, for example, pig iron, whatever you want, usually you have them close to the mines. Why this one? Because they have to process a lot of ore, and in the end, the output is, to some extent, limited in quantity, so you can send by truck, by train, whatever. This is the main reason. If you remember, last time we divided the features of this kind of process production by technology, by management, and by cost structure. We will use also these three kind of categories also to analyze the feature of all the production that we are going to see. Okay, okay. This technology, usually the transformation embedded is not reversible. Okay. I guess that is quite easy to understand that it's very difficult to come back from the glass signal at the end. So it's a fixed technology route. Okay. There is a high relevance and sensitivity to technological parameters. So we cannot change, swap the operation, but we can also not change temperature, pressure, whatever. Okay, high level of automation. Okay, process flow can, to some extent, be whatever. In the end, you have a lot of ingredients put together, so it's synthetic if you want. You can have also different kind of cement or glass in the end. Very limited to some extent in terms of categories, but maybe you can have different products. Management, so decision, in the end, what decision you have to take. We say that mainly, okay, we have this relative importance of management parameters. Please remember, you start the machine, you stop the machine. major decision about how to manage this kind of production system is how and when to make maintenance. This is the idea, okay? In terms of design, is the location, okay? So in the end, when you have it, in the end, is you have to keep this under control. Stop, no more than this. Just to be clear about this, they are producing basic raw materials that are required by many different industries. If you look at polypropylene, you don't have polypropylene that is used for automotive sector or for electronic sector or whatever. You're producing chips of polypropylene. So you have to some extent also a stable without peak demand of this kind of products. So you keep on producing, and you also do not need to take any decision about which is your inventory policy. Because the idea is that you have a warehouse, but in the end, you keep on producing. And usually, as the final product is required by many different industries, if one industry can have some peak of production, the other is a valley. So in the end, the trends are very limited. Okay? Likewise, plastics. Plastic is required, but less and less and less, at least in some region of the world. They are adapting. Okay. If you want, a big issue here, in case of plastics, is about what if my share of the market, my capacity, is to some extent not used fully. So that there is a threshold at which I have to switch off this kind of plant. This is what, as I told you last time, is happening for steel making in Europe. I refer to Europe, not the whole world. But the idea is that large steel making plants and steel foundries are completed, have been completely switched off. Only some of that, I remember Taranto for Italy, is the largest in Europe. But all the other have a smaller size. Cost structure, we already said, very, very high investment. Refinery is between $500 million up to some billions of investment. Huge. Those of you that will follow the course of project management have to deal with how we have to build and follow the activities related with the design and construction of such a plant. Overall, little impact of labor cost, a lot of costs related with energy and maintenance. Now, let's jump into the discrete production. Sorry, this is our examples for nylon, for cement, okay. So, discrete production, manufacturing. So, we will make, as I told you before, discrete manufacturing or manufacturing, okay. We will make reference to fabrication or processing and assembly. This is the terminology that we are going to adopt. Maybe the easiest way is to take a look at okay, this big tree presenting all the manufacturing process of the microfamilies of technology that can be listed in manufacturing process. Here we got fabrications. Here we got assembly. Okay, I think that all of you can understand which are the microfamilies. It's clear that material removal maybe is the king of fabrication, followed by solidification process. Okay, but I think that all the others are very interesting together with the formation. Okay, and the same with assembly. It is to some extent a way of fastening and joining, okay, components to obtain the sub-assemblies or the final product. Okay. Which are the main differences among those? Historical speaking, okay, the main difference between fabrication and assembly is that fabrication have technologies that are transformations that are not reversible. What is the idea? If I remove material, this is a not reversible operation. If I cut, it's not reversible. If I, to some extent, form some pieces, I cannot be back. On the opposite, assembly, at least at the beginning, you just suppose one component on the other, and you try to put them together. So this kind of, let's say, fasteners that you can use, the bolt nut, okay, very good, is to some extent seen as reversible. Okay, this is just to understand, but we know that there is a gray area. Because if we look at process like welding, is it reversible? It's very difficult to say that it's completely reversible. But if we look at additive and manufacturing, we can say that also material removal can be reversed. Okay, so it's easy to, it's a way of, an easy way to understand the difference between fabrication and assembly, but maybe it is not as true in the, let's say, more modern way. But last time we also introduced other difference among those two. One is that usually, okay, fabrication is more machinery oriented. So that when you have, make reference to a specific case, a lathe, you have the machinery and an operator that is operating on that, working on that. You can have this workstation. Remember, we refer this as the workstation. You can have it completely automated, but fabrication usually is quite impossible to have fabrication operation made by humans only. If we look at the assembly operation, the range kind of workstation is wider because you can have completely automated assembly, but most of the assembly operation is with a strong involvement of humans. Remember that we can have just an operator working on a bench, only human operation, let's say, okay? So this is the spectrum of variation is limited, rate of variation. Here you have a lot of. And what is the impact of such a difference? That when we speak about fabrication, is to some extent more deterministic in terms of time, for example, in terms of intervention, intervene on the lathe. Okay. On the opposite, when you act on both in design and management, whatever, on an assembly process, most of the time you have to deal with humans. And the humans, you cannot say, do this or do another things, and they obey. Okay. Not only as they are not machines, the time required for making operation can vary. Even if they are well trained, even if they are well committed, but in the end there is a, let's say, a natural variability of time for operation. And this implies completely different method of design and management. Okay? We can add that maybe some event of strikes, events of absenteeism, events of can happen. So you have to deal assembly, let's say, management decision in a different way, let's say, okay, with respect to fabrication process. We'll say that fabrication is more close to some extent to process, okay, but we will see. The third difference if you remember, is about the flow. We remember that assembly is mainly, most of the time, 99% of the time, is a synthetic flow. So that you need that all the components are ready to be together, joined. Okay? So if we look at a workstation, a bench with the operator that receive with a feeding line, the brackets, on the other you have the bolt, in the other you have all the tools that you have to use it, okay? The idea is that all these components have to be, to some extent, synchronized, okay? And you have to devote some space for those components. If one of these components are just scratched, you can not assemble it in the final product. If we are on the fabrication, on a lathe, okay, you have your usually one starting material in, one steel bar in, you upload on the lathe, you work it, okay, and one product is out. But there is other flow coming out. Shavings, for example, waste rejected, a lot of other things. But you don't care too much about wastes. You put everything together in a cask and you send it to the foundry. You get the difference. In terms of space, in terms of synchronization, completely different. Okay, we will be back to this problem later. But I think it's quite obvious that they are completely different. Okay. The techniques that we will develop for fabrication in terms of design could be applied to some cases of assembly, where there is a highly automatized assembly system. But here we will need to develop another list of design techniques specific for assembly. Okay? Now, if we go fabrication, and again, we are analyzed by technology, management, and construction in order to see the difference between process, production, and then with assembly manufacturing. We can say that, okay, fabrication should be not reversible most of the cases. Okay. The other difference, this is with respect to process production, is that there is a no fixed route. Very interesting. If we are back to the camshaft, okay, what if we swap the cutting of the edge with the first run in terms of lathe? Nothing, because we obtain the same product. After that, maybe it's always better to cut it, head it, and then start turning. But this is an optimization of the process. It is not due, because we obtain at the end we obtain the same object. Maybe with the first one we are less rejected, we are faster, we are okay, but we can swap some of these operations. Second, I said that a camshaft is usually obtained at least in the first round of the operation by turning. Why? Why we can go with milling? Is possible? Absolutely yes. Is it optimized? Less. Okay, especially when we have large volumes, it's far better to go with turning, no way. But we have little car manufacturer, specialized iCar, one-off car that use milling process. Is expensive? Yes. Give better results? Yeah, there is a higher precision, okay? But it's impossible to have, I don't know, my car, because it will be too expensive. But I can choose. Process industry, no chance. Okay? So here, what is the idea? There is no fixed technology and not particular relevance of project technology itself or the parameters. What if, another example, I change the speed cut of the milling process. It's better, it's worse, there is the optimal one, yes, but I can choose a range of different speed. Maybe I can choose to have 3 operations of milling. One is the very first one, very fast and removing a lot of material, followed by another one and, let's say, refining, finishing one. Or I can go with 2 only. You get my point? When you have chance for change, bigger problem in terms of management, in a way, because you have to make a lot of decisions. So that here there is a, let's say, relevance of management parameters. We have to think about, for example, at lead time. We're going to define this better, but lead time is the time that is elapsing between the issue of the order and the delivery time to the client. Okay? I think that is obvious that in process production, the time is fixed. So, ingredients, kaolin on the left, plain glass on the right. In 6 hours, you have it out. Okay? Sharp, perfect. If we look at fabrication systems, it's not like that. We will see. Most of the time often spent in queue or waiting in a warehouse. So in the end, there is a large variability. We can say that there is no more fixed time. We have a higher or lower quantity of work in progress, semi-finished products that are within the production system. In the process industry, everything is perfectly defined. So all the pipes, all the vessels should be fulfilled, and the quantity is always that one. Okay, synchronization, delays. Here we can have delays, okay? And here we have to make decision about a number of different resources. Machine, tooling, people, okay? But we will see. What about cost structure? Being fabrication is leaning more on machinery, is that fixed access relevant impact. Not like the process industry, but usually is higher, at least with respect to assembly. There's always a matter of difference. Okay, and labor intensity could depend if this is more automated or less automated. Okay, we will spend some time on that, but the idea is that you can have, say, workstation that is completely automated with supervisor or with an operator working on it. Let's go with assembly. Sorry, just to make a note. All this, as I told you before, those of you that follow the course on the 3rd year already know is some extent a repetition with some hints on that. All the others, I don't know who you are here, please, if you have problem with this one, be back to me again. I will try to repeat the main concept, but okay, a bachelor student of politics spend some time before, so that if you need some extras, please be back to me, okay? Assembly, technology, management, construction. Technology, okay, what is the idea that not completely reversible, not completely, but this is the idea that if we assemble 2 components, the idea is that we can maybe separate them. And please remember that as the definition of discrete production is because in the final product, both for fabrication and for assembly, you can recognize and you can identify the single components. If you see the car, you can see the different components. If you see the single components, it's easier to think that we can separate them. true or not. Okay. Free technology. Good. What is the idea? Not only we can swap and change the parameter, but in assembly there is a huge number of different combinations to obtain the same product with the same form. No way. This is a strong flexibility, but also imply a lot of choices. So it's very complicated to some extent. On the other side, it's very flexible. It's a trade-off in the end. Process technology parameters. What is the pressure that I have to use? You have a large variety of processes. It is much wider than fabrication. Usually, okay, the process flow is synthetic. Okay. What about the management? High relevance of management parameters. We are no more in the process industry. We are no more in the fabrication, the process production industry. No more in the fabrication process. Here we have a lot of problems. Please remember that maybe one of the main issues about synchronization. So delay is a big issue because you have to mount 10 subcomponents in the same final product, and one is missing. You stop, and you wait for the 10th component to come. So delay can cause a stop the production completely. Being this synthetic. What about cost structure? Okay, there is a lot of situation, large range of situation. Automatize, big impact, of course, for investment. Workstation with machinery and operator less, but most of the assembly is made by humans. So in the end, fixed costs are limited. The impact is very limited. So the spectrum is wider, but we are more on low relevance. Okay? Okay, here assembly for planes, assembly for mechanical components, and before that one, we have fabrication. Please also always remember what I told you at the very beginning. If you go into a factory, you can find both process production and fabrication. Process production, fabrication, and assembly. Only fabrication, only assembly, only process production, assembly. The combinations are a number of that, okay? And please also remember that you can have also process production and assembly, because all the components maybe are worked by a third party, a supplier. So that you produce a steel bar for your foundry, and you have all the fabrication operation done by a neighbor. And then are back for final assembly. And this is, it sounds strange, but in the end, usually it's a matter of cost. You try to minimizing the cost, maximizing the profit to some extent. This is the idea. But this is, nowadays, I'm in a litigation. It's called arbitration, international arbitration for some kind of e-bike. Bike with batteries, with electric engine, whatever. Why? Because they have to understand that this bike is sold in Italy, is assembled, final part in Italy, is assembled main part, main body in Turkey, is assembled the main subcomponent in Thailand, and most of the component come from China. Normal. The point is that additional additional taxation that is taking place in these days, okay, Trump, the war about it, implies different way of taxes that we have to pay at the door. And so this is, everybody is counting again and planning a different supplier for the supply chain. We're becoming crazy. And is an e-bike, is not an automotive, okay? Now, manufacturing, discrete production is preferred. Here you got fabrication or processing. Here we got assembly. And these are listed the different main kinds of production systems for fabrication and for assembly. Okay, we will use this scheme in order to have technique for each of them. So I stop here, but okay, in 15 days, I think, we will be back here exactly, and we will start working with each of them. Okay, I don't want to go into, but one thing, again, as in the same factory, you can find process production together with fabrication production, together with assembly production. In the same factory, you can find this kind of job shop together with a transfer line, together with an assembly shop. So we will learn how to design and manage each of them, but most of the time there are hybrid situations. And we will try to think what is the best one. Okay? Please remember this, because I need to separate, but at the end we need also to merge them into the real factory. Classification by production methods. Sorry, I forget to ask you something. Did you find all the material on the website? Were you able to download? Did you find the recording? Everything is fine with the recording? Apart the first part that is, I remember to start record. Okay. I think that today, at the end, I will tell you later, but I fear to forget. I will upload some additional material. Please remember what I told you at the beginning. There is slides, textbook, okay, and out. I will add, this is additional material. Those of you that are interested could read it and study it, but will be not in the exam. So this is just a warning for that. So don't worry about the exam, but I think that if you are here, you are interested in this topic. And so I add some additional material in order to go into deep. Okay, those of you that think that this part is not, this part, the performance one is not interesting, okay, disregard it. If you are interested, maybe you can read. If you want, you can be back to me. We can discuss, whatever, okay? Use it in this way, but it will be not in the exam. Okay, just to be clear. I will not ask you anything about that. But I think it is useful for you to just understand what is, because these are papers that have been written recently. So that are the last application of, here I'm bringing you the most useful and most that you have to apply. But research and application keep on evolving. Okay, I cannot make a lectures on that one. I use it for PhD students and for managers, for example. But you need some steps in case you can start reading. Classification by production method. So how I create the volume, production volume. Okay, what is the idea here? And I think that some of the features that I will be presenting in this classification will recall process, fabrication, assembly that is on the other axis. Okay, so here you see 3 different levels in the axis. Continuous production, what is the meaning? your production systems start making one product and keep on making the same product without changing any settings. Okay, I think it is typical, at least for process production. I start making glass, I keep on making glass in the same way without changing any parameter. I keep on producing this product. It's apparent that I can adopt this kind of continuous production only in case of mass production. You need it, you always need it. Is to some extent a commodity type product. Flat glass is a commodity. Chips of polypropylene are a commodity. Steel bar or ingot of pig iron are a commodity. Okay, so you keep on producing, and you have to customize a pig iron ingot. Why? In the end, they will remelt it and make it the right shape there. Okay. What is over, I say, history? Okay, things changes, but if in the past, okay, cars nowadays cars are to some extent you can choose most of the function of a car. You can have all the options that you have to choose. But in the past, I come back century, okay, at least, okay, the problem was to have a car. And so if I'm back to Ford Model T, the need was just to have a car. So the way of producing cars at that time was continuous. They keep on making the same car, no option, only black. You cannot choose anything. But the idea is that continuing making the same thing was the best way to produce faster. Okay? Because I'm not losing any time for setting up the system. And if you want a Model T with different color, you have to take some time for switching from black to green, or I don't know. Okay? But it's a lot of time, so you cannot produce that time. Producing always the same color with all the same options means that you can have the maximum volume. And this is the idea of commodities. The other idea is that clients do not care too much about color. Okay, they just want a car at that time. Or in this case, they just want the big iron ingot. No more than this. Or they want the chips of polypropylene. Or this is often used also for low-cost mechanical parts, like washers, bolt, nuts, whatever. Usually, this is the way they keep on producing without any setup and any change of the product. Okay, they keep on producing continuously, they don't stop. On the opposite, coming to the next level, we have batch or lot. I mean, batch, also called intermittent production. What is the idea? With my production system, I need to satisfy different demands, different specifications coming from my clients. So that I will produce 1 week of one product, and the next week I will produce a different product, different within the capabilities of my production system. Typical example, if I look at cars, I can produce cars black from 1 week, blue, I can remember it, okay, for the next one. So that I'm creating a lot. I will stop the plant, making some settings, change of the tint in this case, and I will start with the other. Now, the number of parameters that you can change a car is a lot, so there is a number of different combinations, okay, so a number of different lots. But the idea is that I can sometimes satisfy different demands. What is the problem? The problem is that not only I'm losing time for producing, I stop 10 minutes, for 10 minutes I'm not producing. 10 minutes, 10 minutes, 10 minutes, 10 minutes, I'm losing days of production. Second, the change can cost, if I, always for tints, for painting, if I switch from one color for the other, I switch from black to white. I think that 1 hour of paint will be scrapped. I cannot use it. I'm losing time, and I will pay for that. I have to wash, clean up everything. Okay, make some setting. Ask for a team to make the settings. Not only because if I'm producing 1 week of, I can't remember, black car. Okay. In that week, I will have to produce the number of cars able to cover the demand till the moment when I restart producing black car. So maybe I produce 1 week of black car, 3 months. So in that week, I need to produce the volume of 3 months of black cars, the demand for 3 months. This implies that I'm producing and send the final output into the warehouse. I'm creating a stock. Creating a stock implies space, people, means, and also, we will see, also a cost for keeping the stock. So, now, I don't want to enter any more in details, but the idea is that I can follow demand, specific demands, and this is an advantage. I can satisfy different demand, and I can fulfill capacity for my plant. On the other side, I'm less efficient, at least with respect to continuous production, and I've had some additional costs related with changes, setups, and inventory. It will take time to make decision and learn how to deal with all these things. We will see in 2 months, I think. Okay, but please keep it. Product examples here. I think that most of the product you're getting in touch are created with an intermittent production. Okay. The components, the tools, the car, furniture, but we will see. Third level, always related with volume creation. Unitary or single production. So what is the idea? It is the limit situation of the batch production. Batches with one product only. So if, maybe reference to a production line, the products are then moving down at the end of the production systems, and you see, if we are back to the colors, a black car followed by a blue car, followed by a red car, followed by, so each time you produce something, you have a setup of the system. And it's obvious that you can follow perfectly the request of the client. Enrico Cagno wants a black car. I will produce it. I want a pink car. I will produce it. And I can, to some extent, delight, okay, all the single customer. On the opposite, I must be very, very, very efficient in making setup. Okay, because in that case, with single production, one-of-a-kind production, okay, it means that your production system is so flexible to not suffer from setup. Otherwise, I spend all the time in setuping. Okay, so the idea is that you have to design the product and the process in a way that setup is not impacting. By the way, if you remember, before I say that there is another problem, inventory, that we have with batch production. Here, the problem is solved. Because as I'm producing one product only, exactly for that client, I will not have any or very limited warehouse and so inventory. Okay? After that, so here I would say I'm very flexible, okay, not too much, but efficient, okay. With respect to this one, is a point that, okay, this is only one product. This is every single product is different, okay. But here I can produce a lot more. There is a particular case related with single production, that is a project, okay. What is a project? If we are back to our production line, and we say that we change the color one product to the other, but it also means that you already have the paints, different colors, you have the processes, you have defined everything, so that you're putting in place, okay, what you have already designed before. You just apply what you have already designed. With project, it's a little bit different. It's true that I'm creating one product. That's why it's similar. It's a single production. For example, my Aston Martin, Cagno's Aston Martin with specification. I say I will take Aston Martin. We will modify it. So I go to a small manufacturer. I say, this is my Aston Martin. Please make it with wings, with I don't know, all the modification that I want. So I will give them my specification. They will engineer the specification, and they will develop some process in order to modify that one. This is the difference, because in the line you already have designed this one and you apply different colors. In this case, you have to wait for specification, you have to engineer and then apply it. And maybe most of the time, a project is have never a twin element. So you never make another identical project. Okay, for car we say one-off. Is one. Okay, so that all the engineering, all the drawings, all the schemes will be destroyed to some extent, because maybe the skill remain in the company, but in the end, you will never make that car exactly the same. Okay, why? In the one-of-a-kind production, black car will be made after 3 days there. Okay, the difference is that one. Okay, I will go. Okay, one shot, one hint in that one. We will be back to this concept later on. There is a correlation, okay, between the volume, the annual demand of a product. You see, these are all the products that are requested to my company. I'm making a BC, okay, so the most requested, less in low volumes, okay. When the first one, this one is the most requested product, so the volume, say, is big, okay, big, we have to define it, but say, it's big. This is a medium volume, this is low volume, okay. If we look at the quantities, okay, if we have very high volume, it's a point that we can go for more continuous production. I don't say process, but continuous production. If we go for low volume, it's a point that I would prefer, in order to saturate machines, to have all these products made on the same machines with a setup for changing from one from the other. So I have to produce, I say, 100 pieces of 1,000 different models. I say all this set of products will be produced in this part of the plant. So I need the setup for changing from one to the other. After that, we got okay, medium volume. So keep on. Now we are going to develop this concept. But please remember that the quantity required by the market have a strong impact on which kind of production system we can adopt. The example I already made you about process industry. The volume required is so high that I can have a plant producing only that one continuously. Okay. On the opposite, if I go with production that needs to be customized, I have to go with intermittent production. Okay. Okay. Just a hint. We will be back on that, but try to elaborate on that. Now, classification by market interaction. So I'm producing for somebody. Could be final customer, could be an industrial customer, so the ring after mine on the supply chain. Okay? Here you can see that there are two main kind of way of responding to the market. One is to stock, the other is to order. What is the idea? If I'm producing to stock, it means that I will produce, make my production, and I will put it in a warehouse. And the client will be served by the warehouse. To order is exactly the opposite. I'll be waiting for the client to issue the order, and at that point, I will start operations. Okay? This is the two different ways. Now we're going to decompose it in different, but this is the idea. For the stock, from the inventory, from the stock, or I'm waiting for the order to be issued. It's not so simple in the end, because if I produce to stock, okay, it means that if I don't want to go bankrupt, I know more or less which will be demand. So I can adopt a production to stock system only if I can forecast quite robustly demand. Maybe I can make some mistake, but in the end, I should be able. Otherwise, if I produce something that will be never sold, I will fail. Okay. Second, okay, this situation usually is adopted when, okay, my lead time for production is to some extent too big, too long for the client to wait. So the idea is that the client wants that problem immediately. If the client doesn't have this product immediately, the delivery time, okay, he cannot wait for me to start fabricating, purchasing, fabricating, and assembling the product and deliver it. If you go to market, you go into, you see in the shelf milk, and say, you take one of that or the other, everything is okay. You cannot say, okay, I will wait 2 days for having your milk back. Okay, just to understand. Sorry, but this could be also for cars. Okay, somebody come into the retailer and say, I want this one, some specific features. Or if you need the car immediately, you take it the ones that is in the shop. Okay, available. So what is the idea here? That if the response time, okay, is lower than your production or lead time, okay, it means that production has started far before. Okay, so you know everything, okay, before. But this also means that usually this kind of stock products are to some extent more standard. So the idea is very difficult to understand every single options that a product could be chosen by the client. But if you go with more standardized specification, more standard products, it is easier to have an idea of future demands. Okay, so usually products that are in the stock, like milk, for example, are more or less those ones. So you can more easily forecast demand and you can start production before and everything is fine. So in the end, it is limited to those products. Okay. And usually, of course, those products have also a set demand. Not commodities, but are to some extent close to that concept. Okay. Here we have a number of different products. On the other side, okay, we have to-order production. Okay, to-order production means that I have to wait for the order of the client to produce. Now, here we can decompose a little bit, because here we can have customized, or also referred as repeated production to order, or engineer product, single production to order. In some cases also they are called also innovative products. Okay, what is the difference? In repeated production to order, it means that you're waiting for the issuing of the order and you start producing that product, but you already know how to make that product. So all the design of the process, all the design of the product has been already completed. You start producing. Okay? Or as typical of all the furniture for the garden. Okay? You need it only in spring, I don't know. So they wait for your order, they know perfectly how to do it, they start producing. Okay? But also, remember the example that I made with colors on you know perfectly everything, you start producing. So to some extent, the time they have to wait is just production. So in the end is fabrication of components plus assembly of that, of those ones. Okay? This is also referred as catalog production. Catalog because all the company have them in their catalog. So you ask them, if I want this one, and they just send in production. Work order, production order, they start. It's true that using this catalog, the catalog show you all the different options that have been already designed. They already purchased or maybe all these components before, and you can choose the right configuration of the product. What is the idea? Here you have to wait a lot of time more, because you have to wait the production lead time plus delivery, but you have your customized product. If you go back to production to stock, the product is that one, is standard, but is available immediately. If you are here always in to-order production, we can go with so-called engineered products. What is the idea? Here, the company producing it doesn't know which are the specifications of the product. Is waiting for the order, but is also waiting for the wishes in terms of specification requirements of the product. Sorry. So the idea is that with engineered products, you're asking this company to engineer the product, so develop the product itself and develop the production systems, or at least apply the right techniques in order to produce it. And after that, they will start producing and they will deliver. Again, longer time to wait, huge time you want to wait, but exactly what you think you want. Okay? This is the idea. If you want a one-off car, okay, you are here. Now, we can go into much bigger details. This scheme was developed by Workman, okay, and it's called, okay, custom order decoupling point concept, okay? So, where the process is decoupled in terms of production and delivery, with respect to client and producer. What is the idea? Is to some extent, he broke down what I already explained here. So, what is the idea? If we look at the full process for developing a product and a production system, usually you start by engineering that product, engineering also the production process. When you have all the drawings, okay, and you have all the technology sheet, technology route, okay, developed based on some specification, you will buy all the components, all the material, starting material, components, whatever you need, and this will need time. When you have it, you start fabricating the components. Okay, After that, you assemble the product and you start delivering to the client. Here there are suppliers and there are the customers. Okay, this is the full display. Now, which is the way you want to respond to demand? First way is called make to stock. Okay, this is the more standardized way before we say stock product, but you say. So what is the idea that I define? Listening to the voice of the market and the customer. I engineer the product and process. I purchase components. I fabricate the components. I assemble the components in order to obtain final, and I put it in the warehouse. The clients the customer have to wait only the final part of distribution. Okay? Very fast, very standard product, but in the end, this is the idea. Now, on the other side, you can, again, if we refer to machine tools, like a milling machine, better, okay? There are a number, if you go into retail of a machine tool manufacturer, you can find immediately available some milling machine that are usually the ones that everybody have with standard specification, not let's say, too much powerful, not too much specialized, but they are always useful for everybody. Okay, you can have it in 15 days. This is just for delivery. Now, the customer wants some specific characteristic. So, what is the idea? This other configuration is that you engineer the product with all the different configurations. You purchase raw material, you fabricate the components, but you stop here. So you have a warehouse of fabricated components, but the final configuration of the product is by the client. So in the order, say, okay, this is a later, but I would prefer to have these tools instead of these others. I would prefer the platform in this way of the others. All these components have been engineered and are there, and so they can be put on or not. You can choose. And so this is called assemble to order. I will start assembly when I receive the order. I can choose with respect with the number of components that have been engineered and produced by that. So the catalog is that one. Anyway, but I can customize a little bit. More, no. The idea is that in that one, the other ways is I engineer, I purchase, so I have all the materials, raw materials that can be used for a number of different components, but I do not start fabricating anything before I receive the order. Why? Because that client not only wants to have some specific features in terms of assembly, but want to have some specific component developed for him. Exactly. And this is also another way of, I would say, reducing the risk of having obsolete products. Here, I can have obsolete final product if I'm not able to perfectly forecast demand. Here, I can have obsolete components, but it is true that maybe mistakes with respect to the forecast of the final configuration can to some imbalance. Maybe they require me a different final product, more and less with respect to forecast. In the end, the components are the same, so it's good. Here, from the producer point of view, I have only raw materials, bars or of steel, okay? That in the end can be somewhere, or this is my business, I will use it somewhere in time, okay? So this way is also a way, when you are not able to predict perfectly, is also a way of reducing the risk of obsolescence, not be able to sell, okay? So if we want, here, there is the need of customization, and here is the need of not risking. There is the balance. Purchase to order, I develop all the drawings, all the projects, all the things, but I will not buy anything. In a particular case, okay, less adopted, but for machine tools, for example, is the basement is made with polymers. For vibration, high cost raw material. So you're going to buy it only if the clients want that specific basement. In that case, I will buy it, I will work on it, I will process it, and I will deliver it. And the very last one, okay, engineer to order. So I'm waiting for the specification from the client. Maybe I can develop the specification together with the client. I will start everything I will do, I think. And he's willing to wait all this time. After that, this is theory, but please remember that you are on the market with your company, with your production systems, against the competitors. What happens if you are a make-to-order and your competitors force make-to-stock? You're right. Very quickly, your share of the market will be reduced. Because if the competitor is able to serve directly from the warehouse with the same service level in terms of customization, everybody will prefer that one. And the fact that it can take more time that is hidden, it can better optimize the production. Okay, so that will be more efficient and less costly. So if your competitors go with make to stock and you are make to order, same customization level, okay, you're close to be ruined. Okay, this is also ETO is also sometimes referred as innovation to order. Okay, someone call this. Okay, we already speak about this. So, as I told you, slides are likewise a book. So I took one slide, but after that, everything is explained. If something is not clear, please be back to me. But okay, everything is written in order to have it. Okay, last is let's be back to hamburger. Okay, what is the idea? A very simple example, but I think is useful for setting the idea of the last, but also is launching the next topic we have after the break. Okay, is that remember after the break we go with performance measurement, and here we are to make the stock. What was the problem of McDonald's? Okay, beginning of this century, well, 1999, 1921. Okay, this was the process that McDonald's used, adopted up to the end of the last century. I think that all of you know it. So you have raw materials, so you have frozen patty, you have all fresh lettuce, cheese, you know. Okay. After that, there is the process of cooking, the broiler. There is the assembly process, standard by catalog, but in the end, they do not have the client choosing on the catalog. They will assembly on the basis of demand forecast. And they put it, the finished good on the rack, okay, warm rack, whatever. The customer issued the order, and they are delivered immediately. But please remember, the assembly didn't wait for customer order. Everything was available on the inventory. Okay? A number of problems. A number of problems because they have competitors. As I told you before, at that time, the main one was Burger King and Wendy's. Okay? And the idea is that they can deliver, I would say, a better service and a better product. This was the idea. So McDonald's invest, I cannot remember exactly, number of billions for changing completely the process. This is the idea. So he improved the broiler, improved the assembly, but what we were interested in more is they changed the process, the number of operation, and response to the client. But before doing that, let's go with main competitor, Burger King. Very simple here, raw material, they cook it. The broiler is different, to some extent, is really a broiler, not something like that, so different taste. See? Here we got work in progress. And the idea is that only when the customer places the order, they start assembling the product and they deliver. This is, let's say, the normal way, and the higher level of service, you have to wait some minutes more, okay, but you have your product. When there is a period of peak of demand, okay, in some days, some time of the year, the idea is that some of the hamburger were, to some extent, assembled, okay, the most required one, Whopper. I can remember from all that. Okay, they produce some and put it on the rack, similarly to McDonald's. Okay, this is the way. After that, we get Wendy's. What is the idea? I listened that Wendy's is again back after 40 years in Italy. Okay, we got raw materials back in the end. They keep on cooking like this on the broiler. And if a customer come into and place the order, they took the patty, grilled patty, and they assembled for your position, and they deliver. Higher level of service is perfect. Okay. If the time passed and no order was placed, grilled patty at the end of this was used for creating chili sauces. Very simple. Okay, it's apparent that the number of patties that are put on the broiler is the final basis of forecast of how many hamburger we will be selling. So if you look at this one, remember what I told you with this scheme. Okay, every time you go this way, we are to some extent reducing the risk of having products that are not sold. So that here we got McDonald's that will have the final product. Here we got Burger King, sorry, thanks for that one. Here we got to some extent Wendy's, because the idea that the grill patty is used in every hamburger. Okay, so that somewhere will be used. There is to some extent, a cancel out of mistakes in terms of forecast of the final hamburger sandwich. Okay, because the patty is used, so it's easier to understand. Okay. Now, what was the solution? I will not go into detail. If you want, there is also the description. There is some delays. Okay. What was the idea of the new process? Raw material. Here, okay. So new kind of selection. I don't want you to sell McDonald's to anybody. Okay. New way of cooking, very similar to the one that it was used by Burger King. A lot of investment about how we have to keep the grill patty warm in the right way, not losing the crispness. Okay. The idea is they assemble when they place the order. Okay. I don't want to enter in further details, but the idea is that all this, you see all the process for designing it. Okay. With video screen, with, by the way, all the things that you see now in McDonald's were developed 25 years ago. Exactly, there was a leap in the technologies. Just to understand, and Burger King and Wendy's followed. Okay, this was. Now everything is nice. We have to understand. So McDonald's before and after 1999. Okay, before it was a made to stock, pure made to stock. Okay, after with the new process, we go with let's say an assemble to order. Maybe something is made to order. Let's say is here more close to assemble to order. Okay, this is the idea. This was the switch in terms of process. So, which results? They have some of the restaurants, okay, running the pilot projects on that one. And in the end, okay, they have to measure results before and after. So criteria for production capacity, absolutely interesting, the quality of the products, flexibility of the client, accuracy of the right things to be done, and responsiveness. Oh, which performance? Okay. If you look at those production capacity before, after, high and high, we can say that maybe capacity increase a little bit. Even if we shift from a make to order with respect to shift to a assemble to order instead of a make to stock. But technologies have changes in the between. Quality, low. It was a problem. It was a problem. That was the problem, the issue. Now it's high, comparable with all the others. Okay. Flexibility, high before, high after, in a different way, but it changed. Accuracy, you know, I have never got problem of accuracy, and so the new one. Responsiveness, time, fast food, time for serving. High, it was the criteria for success of fast food is responsiveness. New McDonald's, relatively low. Why? Because with the new process, you have to place the order, wait some minutes, and you are served. If you're a mother coming into with a 4 child, You say, I would like to have four hamburger, whatever you want. Give me. I have to feed children. And the point is that for the customers, McDonald's has, this was a big issue. What is the results? They went back to make the stock. Okay, I can say that is the opposite of what I told you about competitors. But the idea is that the shift and the changes that you can make should be always followed by understanding which are the performance that you are delivering. And if those performance are the ones that are expected by your customers. That was the big mistake. This is the break. This was the big mistake of McDonald's at that time, strategic mistake. What was at the end, they come back to make to stock, but they save all the technology that they developed. So they readapt all the technologies, the videos. What you see now, there was developed 20 years ago in the end, but were readapted to a made stock. Okay, so this say that what is the importance of performance measurement that we will start in the next block of lessons. Okay, so there are some examples if you want just to come on. Okay. Okay, you can have it. Okay. If you have problems saying about this, there is some videos here. Videos. Okay. With the idea of classifying that one, if you want, take your time. Just do it pretty easy. Yeah? In the end, to make it. Okay. So, see you in a quarter. Okay. If there is any question, I'm here. Again, please remember me to restart. It's my nightmare to forget. Okay. With this block of light, we are going to open up a new topic. Okay, that is related with performance of production systems, and I would say related products, because in the end we cannot separate, to some extent, production from this production systems. Okay, what is the idea about measuring performance? Now we will see more in a more detailed way, but the idea is that we have to understand what's going on. Okay, understand what's going on, also because when we have to take decision like McDonald's, we have to understand if what we are planning to do will drive you to better or lower solution. Okay. One of the main point is that I want to highlight about measurement, that we will spend some time in defining what is a performance measurement system. I will spend the first 10 minutes, and defining that, understanding how the system of measurement works. Why this? Because usually a production system is a complex system. So we have, to some extent, to guarantee that we are able to measure at least all the most important performance, okay, most important areas, and not losing any of them. Because if we are not measuring some part of them, some issue will come from that part. From that point, if you will read the papers about more recent research about performance measurement systems, you will see that my assumption, my hypothesis on that one, is that the problem of sustainability is also a matter of disregarding some performance with respect to the others. I don't want to enter now into details, but economic, social, and environmental performance. And when we ask companies which indicator they use, it's quite apparent that they use a lot of indicators for economics. They know everything about economics. Okay, and those indicators are quite standardized. So it means that these are centuries they measure in that one. You measure what you are interested in. Otherwise, you don't measure. Nowadays, at least larger companies measure a lot of indicators for environmental, CO2 related to most of them, in a quite, I don't want to say fuzzy way, but at least is not precise way. Okay, they are just testing which indicator works better. So they are not standardized, and they are all completely overlooking social indicators. If you want, you can have, and this is, from my point of view, the problem of sustainability. Sustainability, I can tell about production systems, but I think it could be enlarged to other topics, because if you're interested only in those ones, you're performing only in those. You measure what you are interested in. So the fact that you have other indicators that can tell you about the remaining part of your production systems is, to some extent, at least the starting solution for increasing the awareness, increasing information, because maybe you never thought that this performance was important. So the systematic analysis of performance and indicators, from my point of view, is to some extent quite important. Another focus that I would like to propose, but we're going to speak a lot, so you will find it later, is that we are going to measure, okay, but please remember that when we say we are measuring, it means that we are looking in the past. So we can measure what has already happened or is happening, okay, but we are in the past. Present, past, present, whatever, but in the end, past. And the problem is that you, in the end, you're not interested in the past, but you're in the future. So there is a underpinning assumption that what has happened in the past could be projected in the future. So that if I'm measuring availability of my plant, number of failures, whatever, okay, the idea is that if I look in the future, I expect to have the same situation in the future. But only if I broke down all the performance, and I have to say every time if this performance could be similar or can be worse or better, or this intervention is going to act on this one, and only after I can project in the future. What is that projection in the future is so important? Because maybe the very first question is about telling you internally, but also with respect to your customer, how much you will be able to produce. How much in terms of good quality, in terms of respecting the demand of the clients. But let's say on December 2025, you have to tell what you can or you cannot produce in 2026. Is the production budget for the next year. So to some extent it's very important not to accept order, not to accept order. If you accept order that you cannot fulfill, it's a disaster in terms of penalties, in terms of reputation, in terms of whatever. And this is the idea. So we start from okay. Again, we start from zero on the objectives. What is the main objectives? Okay, to learn from the past, as we said before, but the idea is what is right, what is wrong, what is going right, what is going wrong, okay, and to some extent is needed to understand what has been done, okay, in the past. This is the idea. Second, take the right decision. Right decision, and also try to monitor and control intervention that has been implemented. Okay? So now I have to take a decision if to go or not go with some intervention that I want to make in order to improve or redesign the plan, change in the management, whatever, change of the product I want to produce. And after some time, like because I have to measure again in order to understand if a result has been obtained or not, or if other indicators tell us that some other performance dropped. Okay. In this, it's clear that the problem is also to perceive what is called signals, weak signals. Because I would say that strong drop in the performance, okay, quite apart, maybe you didn't need to measure to some extent, but a good performance measurement systems can also understand with some anticipation something that is going to happen. If we go back to responsiveness, the fact that McDonald's made some pilot implementation is a way of measuring and try to understand what could have happened before the taping out of the solution. Okay, but also we have to understand what is the company status. We are going to separate what is a performance with respect to the operative condition of the plant, and we are not to mix them up. Okay, but also understand also which are the variables describing the external conditions. So we are selling less because of the exchange rate. Point is that it's not a problem of production. Maybe this external condition can change future decision about where to produce, not to produce. Okay, but in the end is exogenous. Okay, but also understand what the client wants. You have to keep an eye on that. And taking right decision means also to improve also not only the quality of the decision, but also the timeliness. These are to some extent expected, but I would like to add a third category of objectives that is related to the motivation. Very important. Usually is overlooked, but the point is we measure to motivate, okay? Because we have to tell our employees, the workers, whatever, or managers, what we have obtained or not obtained. Okay, let them know. And this is to some extent very important because sharing results can motivate a lot about what you are doing. You have to trust about measurement, whatever. But the idea is that if everything is clear, that you know exactly the situation. Moreover, you have to measure the result of every single person. This is very important because the idea is we can have a price on somebody, we can act on a single, we can maybe have a specific training for a single person. He has not said that maybe a department is going wrong because of one or two people only, why we have to act on the whole system or the machinery, or the same. Okay, and this is to some extent to incentive to discourage employees. But okay, it remains always the same sentence by Lord Kelvin about we cannot improve, okay, what we cannot measure. Now, framework, okay, as I told you before, production systems are very complex systems. Machinery, humans, interface, interaction is a mess from that point. And so we have to choose the right number of indicators able to get all the information from these systems, so be systematic, But please, on the other side, measuring a lot is an effort. So we should measure exactly, but no more than the minimum required. And this is the problem, okay? Usually we refer to this system as performance measurement system, PMS, okay, or performance measurement framework. And the idea is to identify so-called key performance index. We have a number of different indexes, as I was telling you, some of you before. If you go on the paper about PMS, we try to understand how many indicators were used for manufacturing companies, and the number is close to 1,200 different indicators. Understanding which are the right one from a company is a key objective, okay? With the idea that for a large company, say 100 could be more or less 100, 150 could be the maximum. I remember some years ago, I've been working with Coca-Cola on one side company and Nestlé on the other, and they were running with 140 and 120 indicators. Okay, after that, sorry, indicators that they deploy in different situations, but the idea is that this is the number, this is the maximum. These are large corporations, larger companies, okay? If you're smaller, eventually it could be, to some extent, shaped in the right way. Now, what is the idea of what we have to measure? Okay, the set of indicators. Perfect. Second, okay, which is the metric you want to use it. You will see that we will introduce some performance, we will introduce some key performance indicators, examples, okay, and in which way we can measure them. Very simple for an engineer, but okay. The other thing is, which is the frequency of measure? Every year, every 6 months, every month, every day, every second, okay? Okay, nowadays with the information systems that are available, we can measure almost everything. The point is, after that, we have to analyze them, understand, and reuse it. So, but the idea is that we should have some target also on that one. And the other point is, yes, well measured, but which is a good performance or a bad performance. We can compare with best data. We can always improve. But the idea is what others are doing, which is the target that we set for the company, and which is the benchmark, if you want, to make it with your competitors. Please remember that performance measurement is so important that, let's say, competitors like, I remember Mercedes, BMW, Renault, Volvo, and Ford, okay, because I was there, decide that they want to know which is the number of hours direct labor used for a chassis. Is one of the indicators, and the energy used for producing it, okay? And so there was a third consultancy company out. They defined perfectly only that specific part of the process, not the whole, okay, just to not share too many information. And this company measured exactly how many hours, how many kilowatt hours, hours of labor and kilowatt hours of energy were used, the material, the efficiency for that particular specific. So it's so important measuring and setting targets and understanding what the others are doing, that competitors, because in the end they are competitors, prefer to share information in order to understand this. You get the point? On that one, if I remember correctly, Renault had the best results, number of hours of direct. And, okay, performance, but also responsibilities. So the point is linking always that performance with somebody. Now, distinction. We have to make some distinction. Some of you already took the exam of measurement. Yes, I know. So some of this distinction already happened, but also here are important. So we have to distinguish between performance and operative conditions. And we don't have to mix them up. So what is the idea of performance? That are the results of the production systems, okay? Measure with a number of different scale, multidimensional, okay? Operative conditions are external and internal. We'll see that difference. Characteristic of the context in which this result is obtained. Just to understand, here we got our production systems, okay? Here we got one of the internal performance could be, how we see better, okay? The percentage of waste, like intercepted by quality control, the effectiveness. An external performance can be the delivery lead time to produce a compliant product. We have a list of that, okay? And an internal operative condition is the level of machine obsolescence. Okay, so what is the idea? Is that the level of machine obsolescence is not a performance, but it can, to some extent, impact very much on the effectiveness. Okay? But we don't have any performance related with operative conditions. This is an internal. And in this example, you can also understand that not only an operative condition can have an impact on the effectiveness, that is a performance, but also this performance internal can have an impact on another performance. If you have a higher level of effectiveness, you will have higher delivery time. No way. Because if you have a number of defects or rejected products, you need more time for producing, so that you will be delayed in fulfilling the order. The effectiveness depends on operative conditions, internal. No way. So you see that there is a causal link, but please remember, performance are different from operational conditions. Okay? Maybe we can act on operational condition in order to obtain higher performance, but obsolescence is performance. Okay, internal and external is always like that. Why is it important to distinguish between internal and external? Easy, because internal is part of your organization. You should have more power. You can't say a more command on internal personal people and the situation. External, you can ask the other company to behave like that. After that, there are also situations where you have suppliers that are so weak with respect to you, they have so much bargaining power with respect to them that they are following you everywhere. But it's a specific situation. So, external performance directly measurable from outside of the production systems. Punctuality experienced by the client. And this tell you that if this performance is experienced by the client, is to some extent much more important than internal. Even if usually external performance depends on internal. Because these are directly experienced by the client, so you're going not to sell anymore. Internal performance, okay, performance whose measurement is of specific interest of the company, but not by the client. Material productivities. How much steel, plastic, whatever, I will put for each product. And with operative conditions, usually we refer to the state of a process or way of working that can influence a certain performance. Please remember that not always, but this one interact on this one, that interact on this one. But we can have also a direct link with this external, okay? Also here we can have both internal, external. So if machine oscillation is obviously internal, exchange rate variability is something that could impact a lot on which kind of distribution production we can make or not. Again, we are back on the taxes that we have to pay after the war of taxes that is taking place nowadays, but some market nowadays will become closed. Distinction number 2. The point is here, if you think of a firm, industrial firm with the production system side, okay, the same concept of productivity, how many pieces we are creating per hour, have to be applied differently, okay, even if the indicator is the same, the metric is the same, but the concept, I think, is quite easy. If you are applying to the single worker of the assembly line or the whole assembly line. Why? Because they are working together, they interact, but not in a linear way. So that it doesn't mean that if the productivity of A, B, and C is high, productivity of the assembly line will be high. Maybe, okay, maybe it could be medium. But the idea is that there is a matter of interaction. And the same, the production components, assembly, and the finishing for that one will not respect the productivity of the whole film. Because maybe one is working on 2-man shift, another on 3-man shift, and we have some synchronization problems. Something very quickly, okay, about the design of a performance measurement systems. This is to some extent, okay, it's a little bit more a simplified decision. What is the idea? This is the idea that you have some objective to be achieved, and they change over time. Could be, for example, increasing the production volume or the productivity, if you want, in a specific period. The decision maker have to take decision, changing over time, that will change the status of the company. Okay? And this company will make some performance varying over time. I remember, okay, the objective was to increase productivities. We have some problem with external, okay, engine production, okay. We have problem with some suppliers about porosity of material. You know that when the tool goes on porosity, have some vibration and can break, okay. And on the other side, we have problem with water. When you use water in the process with oils to have the material removal. What was the problem? On material we have porosity. On water, there was the exchange, use of water from drinkable water to surface water. Decades ago, in Italy, there was a specific law that say that companies cannot use water coming from the aqueduct, but have to go with wells. The problem with wells is the biological burden. So you have to use chloride in order to kill the biological, but if you use chloride within this water, when you use it on the machine tool, this make this oil more, I'm missing the word, the opposite of dry. No, sorry. Dry was the, again, okay. I tell you the right word, it was no more wet, but it was drier. So that when it cut very quickly, it broke down again. So the point was related with decision about the choice of new tools to be used, and the external conditions were, to some extent, related with porosity. So they choose tools that were more able to deal with vibration. By the performance at the end was not the one that was expected. Why? Because there was another external condition, water with chlorine inside, so that they broke more than expected. So you make an intervention in order to improve, and in the end, you obtain the opposite, I would say. What is the point? Is that, please remember, there are some external conditions that you cannot measure, but you don't know you have to measure. We understand after. Okay. We have a different performance with respect to the ones that we expect before, and we have a perceived performance that should have been better, and in the end was worse. Okay? But also, if I may, there was a different perception of the status of the running of these machines, Please remember that all we are measuring is always subject to a mistake, could be subject to a mistake, and a delay. In that particular case about water, okay, when we measure the quality of water, there was a delay, so that we took 2 months to understand that water was the problem, because we have data that were of the previous month, where we have the porosity, but not related with water. Pardon? Not observable because we didn't think it was important. When we understand that it was important, we measure it, information was delayed. Okay, and this is the way things are running. So you're always late, timeliness, remember what I told you before, and maybe we have some mistakes. Mistakes covers weak signals. Because the problem of vibration, porosity, cover the problem that some of the tools broke down because of water, not because of porosity. So we keep on hitting on suppliers, say the foundries, why you have so much porosity? We don't have porosity. You have it because our tools are breaking down every day. And it was not their fault. Okay? So that we have another external condition that covers the weak. Okay? And we were not so precise in understanding this. Uncertainty principle. Again, what is the idea? When I'm measuring, I'm changing the performance. I think that all of you that have the course of measuring, when you're measuring, okay, if you're not using the right tool to measure, okay, if you're measuring temperature with a big thermometer, the temperature you're measuring is the one of the thermometer, not of what you want. Okay. Okay. When you're speaking about complex production systems, the things that goes worse. What is the idea? Because we have also the organizational side. Okay. So when we measure, we have a direct effect. This direct effect is linked with motivation. What is the example? We need to measure punctuality. So delay in delivering. Okay? We have different indicators that we can adopt. But if we choose one indicator or another, we obtain a different performance. One indicator could be average delay. If we measure average delay, okay, we will have many jobs late, but a few days. People adapt in order to have a low average delay. Instead, if we use the number of delays, number of jobs that are delayed, we will have few jobs with huge delays and all the other on time. So try to think, maybe if you link this indicator with some price or some action, okay? It's a point that if you go with number of delays, I want to reduce the number of delays is one of the dimensions of punctuality. It's a point that one order go 1 second delay, they leave it. They will not recuperate. They will go on others that are on time. Okay, they prefer to sacrifice one of them, and so that one will be never finished. On the opposite, okay, with average delay, in the end, it's better to have all of them with little delay. Different measure different performance. So every time we choose one indicator, we have to think which could be the impact. And in some cases, the solution could be adopt 2 indicators, okay, in order to have a full understanding. 2 indicators means that you have to measure double with the problem, okay, the trade-off in terms of. This is the direct effect of measuring. The problem is that there is also an indirect effect, okay? That is more related not with motivation. I will try, in this case, I will try to reduce the delay because higher price, but because of expectation about the future. Example, we will see more and more after that for when we have to design production systems, we have to understand which is the expected, okay, productivity of people, operators that are working on the plant. So you try to plan everything, you can design everything, but in the end, you make some pilot workstation. So you have a lathe, you have a well-trained operator with some experience and a lot of expertise, and you start timing. So you have a number of casks of products, and you have to produce 100 of this one, 100 of that one, and together with the union state informing everybody, because everything is there, you have to some extent, tell it. What is that from the 2 perspectives? From the perspective of the manager and the perspective of the workers. The manager would like to have the real value, which could be the average expected productivity. Because the idea is, if I know which is the true value, I can predict which will be the real, okay, production volume. In case I can train workers more, okay, but I can also understand which is the target, because this is the target. If I produce more, means that we are running better, worse, something like that. Let's see it from the worker's point of view. Expectation. First situation, you select one of the workers. Usually, you select one well-trained worker. In the end, is not the average, but is somebody that undergo a training process. Okay, you select him or her. You use that as a sample. Very important. When he starts working, it'll speed up a lot. So workforce productivity, 200 pieces per minute. This is good or not? Absolutely not. Because I expect this plant to have projected the production of 2 million pieces. And I will never get to that point because all the others will not behave in the same way. So everything, all my projection will be wrong. the opposite, structural behavior. This has been selected, say, the thing is about expectation. If I go too fast, I will never get the price for productivity at the end of next year. So it's better if I slow down 50 pieces per minute, okay, only, so that next year they expect to produce 1 million of pieces. We will produce 1.5, and we get extra price for production. Okay, I'm exaggerating a little bit, but this is the idea. So the fact that you are measuring, and they know that the manager, but also the managers, the people know that they are measured, change the performance in a way, in an indirect way. We will see that this, let's say, standard production rate will be one of the things that we will be working more. So this is, to some extent, very important. Now, always related with design of production management systems. There are some properties that performance management system should have. Some of them we already considered. Timeliness, we said before, so I wouldn't say so. We need to have the information return with a very short delay. Completeness, I already told about this. So the idea is that we have to cover all the main aspects. Okay. Oriented to the right period. Sometimes they also link to timeliness, but the idea is that I need indicators, okay, that are not, to some extent, maybe taking the little fluctuation, but look at the final. So for productivities, maybe I need an average indicator in order to have a final, final good, okay, measurement of what we're doing. Try to focus on specific responsibilities to understand where we have to act or not. Precision. Weak signal, able to understand little variation in case it's needed. And last one, okay, is so-called measurability. So the idea is that we can measure performance more as possible, okay, quantitatively, okay, and in a way that is objective. Maybe of the two, I would say that objective is more important. Quantitative is possible because not everything, when you are interacting with organization, can be quantitative, okay? And so some of these indicators could be just understanding is plus plus or minus minus, just because it's a perception, okay? Okay, these are, let's say, static, okay, properties, but there are other two that maybe are more important than one that are so-called dynamic properties of production management systems. One is related with maintainability. What is the idea? I spent 2 years, so this is the time needed, to set a performance management system. I select, I use the metrics, I understand which are the KPIs. I tested 2 years because I need to make at least 2 measurements of the whole. So 2 years are needed. Okay. And after that, or the meanwhile, we have to change some machinery, some departments. It happens. So the point is how my performance measurement is robust and can be readapted to the new configuration of the system. How I can reuse data that I have. Because I know that some of them will be lost, but some other, for some machines that are transferred, some others, maybe at lower level, can be reused. And this is a good way to have a system that is running, although we are changing the production system, redesigning, managing in a different way, whatever. And okay, second, that probably is related with cheapness. Nowadays, data are more and more cheap. Okay, it's true. Nonetheless, there are things that can be, so gathering, and so in this case, elaboration, become more and more impacting in terms of effort. Now, data have been driven by all this sensor. Elaboration with AI. By the way, some of you, I hope, will use AI, okay, I use AI for my limited field for production systems. The best way for using AI within companies in production systems is using all the information you have. Because nowadays, we are in a moment where we have a lot of numbers, but we are not able to link them. Okay? On this basis, two of you, in the last 2 years, create a startup, two startups about AI in production systems. I put here and there. I don't know if you are late or not, but I say 5 years ago was a good idea. Okay? Try to think, because everybody thinks to use data, artificial intelligence for other things. But if you think that a number of performance, a number of information about how your production system is running are in the systems but are not used, are in this file, on the other files, are on that person, on the other. The point is, take a red thread among one or the other and understand what's going on. Now, something about performance. Again, some of you from the bachelor already see this scheme. I need to repropose this one. All the performance can, to some extent, reclassify if they are more linked with efficiency or more linked with effectiveness. Okay, so we have to understand to some extent what is effectiveness and what is efficiency. If you say this vector, say the system output could be the kind of product that I'm producing. And the other vector is representing the kind of products that the client wants. I think that is quite easy to understand that only the projection of the system output on the client needs will represent effectiveness, because you are producing that share that is needed by the client. Okay? Or have the performance required by the client. So if we are back to effectiveness, effectiveness refers to how useful it is. So doing the right thing. On the opposite, we have efficiency. So we are taking this one, this vector here, and you say how many resources you use to make this system output. How many hours of direct labor, how many, how much money you're going to use it, how much material you use it, whatever. Okay, for obtaining this one. So in the end, if you want, efficiency refers to how well you do something. So doing the things right. I think that is quite obvious that doing the right thing is much more important than doing the things right. Both are important in a way. But if you are doing well things that are wrong, it's useless. Okay, I would say. Okay. Here are some examples, but maybe I can dig back again on the automotive sector. I'll just make classic examples. Okay, on this one, it's clear that all the US manufacturers, car manufacturers, at the beginning of this century, produce cars that were not wanted by clients. This was one of the reasons why most of the biggest, largest car producer in US dropped immediately. Detroit crisis, okay? On the other side, if we analyze which is the efficiency, so how many resources do I put to develop a new car or a new production system for production that those cars, you can understand the results of this. And here we have, okay, several examples. BMW, Toyota, usually are highly efficient. But something are changing. Fiat, let's say, after 90s, not so good, okay, but the same Volkswagen, okay, they try to have a lot of brands, a lot of models covering everything. In the end, okay, was not efficient. They try to have, whatever was the idea, initial idea of Volkswagen Group, to develop modules that could apply in every kind of cars, in every brand. So Seat, Volkswagen, Audi, they can reuse it. So they engineered, they make a huge effort in those platforms to be reused several times. So they can increase the volume of those solutions and so save a lot of money and have a higher level of quality together with a high level of customization. They have all this platform in a shelf and they can take it and make your car. Suspension system, chassis, whatever. What was the problem? And we know it in the last 2 or 3 years. They were not so efficient because they put too much money in this engineering effort so that they will never get back from those investments. They were not efficient. Okay? Just to understand. Now, this is a performance framework. We'll go through this performance. As I told you, is to understand limited, but these are the most important performance that you have to take control in a production system. As you can see, this performance are in a quadrant of quality, of service, of flexibility, of productivity. Okay? After that, customization is in the quadrant of service or in the quadrant of quality. In-house compliance is a matter of quality or is a matter of productivity. They are overlapped, the quadrants, no way. Okay? And the other point is that within the same quadrant, the ones that are top left are more related with effectiveness. The ones that are bottom right are more related with efficiency. For example, for service, assistance, pre-sale, and post-sales, now we're going to see, are more related with effectiveness, more related with, I would say, external performance, effectiveness, while promptness or flexibility are more related with efficiency, internal performance. By the way, they always have a share here and a share there, but most of this. So, for example, here I got assistance, pre-sale, and post-sales. Maybe 2 examples on that. Assistance that the manufacturer, okay, gives to the client or final customer about their product or production system. Please remember that now we cannot disjoint the couple production system and product. So, for example, when Shell needs to have a new refinery, okay, make a call, and we have different contractors that make their proposal, to say, we will design, we will procure all the material, and we will erect your refinery for you. and this is the final price. Make a proposal. Shell look at those proposals, and one of the performance that are considered, this is a project, okay, is, for example, assistance. Assistance in two ways. Pre-sales, so the ability of Saipem, Italian main contractor, to well explain what will be the project with all the details required, with all the assurance about what will be done, pre-sales. But also, usually, Shell look at what are the service post-sales. So you will finish this oil refinery in 3 years, okay? But are you able to provide me maintenance services, supportive maintenance, so with all the spare parts in 24 hours when the failure happens for the next 10 years? You get the point. So Saipem have to deliver the oil refinery in 3 years, but have to guarantee that he will be able for the next 10 years to intervene with spare parts, whatever, in 24 hours. It's apparent that this is a performance that is quite easy. If we go with cars, I think that many examples are available. I think that Japanese help taught us how to do assistant pre-sales and after sales. Lexus in the United States started. So the idea is that you will present differently to each luxury customer what will be the product. And assistant post-sales is that every kind of planned maintenance, there will be a service, a wallet service about maintenance. After that, all the other premium car manufacturers adopted it, but they were the very first one. Okay. Now, in-house compliance. Okay. Oh, in-house compliance have to deal with productivity of the material. We will see also, I will say later, that we have a specific focus on that. But the idea is that in-house compliance have to do with defectiveness, rejection that could happen within the production system. Okay, for example, we can have number of rejected production over the production. 10% of the final product is rejected because it is not compliant with the standards. Could be at the final, could be on a specific machine, could be on a share of the process, could be calculated. Okay. Usually, this kind of indicator, okay, refers to so-called material productivity, and could have with rejects and scraps, but also can be related with, in terms of, for example, steels. Remember, we have the camshaft from the bar. How much steel have been removed from the bar in order to obtain the camshaft? Please remember that that waste will absorb all the energy, the time for doing that. If we have less material to be removed, we reduce energy and we reduce the work. So this is a very interesting, okay, measure to be done. 3, all the performance will be presented by examples. Another thing is that we will present, as much as possible, examples, both physical and economical. Examples of in-house compliance could be number of reworks. Okay, this is a particular situation when we have a rejected after an activity, an operation, the product can be reworked and made compliant. So the number of reworks could be a measure, a physical measure of the quality of the process. Less rework, okay, higher quality, in-house quality. This means that at the end, I will have 100% of the flow. So all the process will be compliant at the end, but because I'm going to rework it. This is possible with mechanical parts, usually. Mechanical parts of a higher value. But this indicator is not possible to be used. For example, you remember that we speak about continuous production, low-cost metallic components like washer, nuts, whatever. If we think about screws, it's just rejection. We're not going to rework them because the cost for reworks will be too high. So that in that case, we start with 100 units of starting material and we end with 90 screws. Okay. In case of rework, we have the same number of starting material at the end, good product, but we will rework it. What is the idea? We increase the cost for operation. These two different ways. Okay. In case of reworks, another indicator that could be useful will be the percentage of reworks on the total of production cycles. So, which is, we have different production cycles. Okay, we sum them up, we sum all the reworks, and we understand globally or locally, which is this percentage. We can aim at each of them and understand. Or the other physical indicator is time spent in reworks. Different ways, okay? Number when intervention reworks is standardized. So it takes always 2 minutes to be reworked. Or if it's more complicated, it depends on what happened. Maybe time for each of them, so total time, is more interesting. Every time the product is of a higher value, more we go with the time spent in reworks. A typical economic of this one is the cost of rework calculated on time or calculated on number. Okay, depends. But in the end, reworks usually implies the use of personnel and use of machine for a number of minutes, hours, days. Availability, always in the, let's say, productivities / quality quadrant. Availability with the star, why? We have availability here and availability here with two different meanings. Okay, this one with star, we already meet we already meet this availability linked to the concept of reliability with failure. Okay, we are speaking about reliability of a machinery, reliability of a system, and maintenance and failures that can happen. Okay. If you remember, what is the idea that we have some physical indicator standard, okay, that we can have for single components of the production system or for the whole components. And last year we understood how to calculate at different levels. But the two main indicators were mean time to failure and mean time to repair. What is the idea? Mean time to failure is the time when machinery or system can produce. Why mean? Because usually you have different time of good production, so you make an average in order to have a more robust data. Mean time to repair is the time for having maintenance intervention. So that mean time to repair is the time where we cannot produce because it's out of work, out of order. Okay? If we want to have the economic valuation of those one, the cost of lost production is maybe the most adopted one. Cost of lost production, because during the time for intervention, for the maintenance, we cannot produce, we are losing time for doing production. If the machine is not working, we are saving variable cost because we are not spending the resources, but we are not getting revenues. So in the end, we are losing the margin. So those products that in that 2 hours are not produced, we can appraise them by the loss margin. This is called the cost of loss production. Moreover, we have to remember that we have also a cost of maintenance, because the intervention itself have a cost. Okay? And this cost can change if maintenance is corrective or preventive predictive. What is the idea? If it is corrective, you run the plant, the machinery, the production systems, and when an event happens, a failure event happens, you act trying to repair it. On the other side, with preventive, okay, you know that more or less a failure will happen in the next month, and you immediately plan the intervention. So you anticipate the failure, substituting that part. Okay, this is the idea. What is the impact on the cost of maintenance is very important, the difference. Because in this way, try to imagine what is going to happen in the factory. Something stop, maybe there is some noise. You have to understand what has happened. Okay, open that nobody was hurted, people no injuries. Okay, but it could happen. Okay, you have to understand that the problem is in this machine, so you have to dismantle good part, find the problem. Time is passing. Okay, you look inside, you understand what has happened. Time has passed. Hopefully, maybe only a belt was to some extent need to be changed because it's broken down. But it could happen that the belt or the chain destroy other pieces. Longer time, you need spare parts. Maybe also the team that is analyzing the failure need time to come into. Time pass. Now, we have the spare parts in the warehouse. Okay, immediately we can fix the problem. We have to order those spare parts from a supplier. 2 days. Time. After that, we fix it. Okay, and we restart it. So in case of corrective action, a lot of time before repairing passes. If we go with preventive, it means that you plan that on Saturday, when nobody is in the factory, the team come into, take the belt, put on the other arm, finish. No impact on production. It's true that maybe you are going to substitute the belt before, maybe you are losing something. Okay? And also a preventive maintenance asks for a number of decisions, an effort in management that is higher. So corrective and preventive could be, most of the more complex production systems go with preventive. It is very, I would say, Please remember, process production goes only with preventive, no way. Because a stop in that kind of plants that is capital intensive is not possible, okay? But maybe you can have, let's say, more cheaper machines, simple situation where you can adopt some corrective, or maybe both of them, okay? Sorry, I didn't say something about preventive. Okay, you know how many hours that belt will work safely with a 90% of probability that it is not broken down. But you can have also predictive. Typical example, there are some sensors that perceive vibration or noises. If the level of vibration and noises goes too high, this is a weak signal that something is not going right in that machine. And so ask for a check. Likewise, with cars, when you say a whistle, means that belt is close to broke down. This is predictive. Preventive, after a number of kilometers. Corrective, when you stop in the highway and you ask for intervention, okay? In-field compliance. Okay, what is the difference of in-house and in-field? In-house, what is happening internally. In-field means that your production systems or your product is already in the hands of the client. So this is perceived by the client. This is why this is, to some extent, a measure of strategic importance. Is a step, okay? So it's a matter not about how many scrap, rejected, waste I made it producing that car, but how many times that car is going to stop or failure when it's out, or how many times your production systems that you deliver to your client, okay, is going to stop for failure. Okay? Some indicators, physical and economic. If we look at production, number of returned products. I don't like this PC, this phone, please have it back. Okay? I don't like this car, please have it back. There are some policies for returning goods. Some other are contractualized. Some other are more weak. Another very good indicators is the number of intervention under warranty. Why? If you go with electronics, you have 2 years of warranty, in Europe at least. And if it's under warranty, it means that as a manufacturer, I need to pay for those interventions. So I know perfectly which are the intervention, the kind of intervention, the cost, the number, the date, everything. This is a very good indicator. Only with intervention under warranty. Economic, okay. For example, you can translate the cost intervention in terms of cost. It would be good to understand which is the cost of lost reputation. It's apparent that if you have a lot of intervention, then warranty usually more and more thinks that your product is not reliable as competitors want. Very difficult to estimate, but to some extent, this is to some extent a very weak and difficult to quantify signal, okay? But it's crucial. Customization, okay? Okay, my system, production system, okay? How many products, variants, models, okay, can offer according to special design specification of the client. This is the point. It's a point that here the role of research and development, because please remember that all the variants from the models have to be engineered before and provide to the clients. So when I speak about modules that you can compose together in order to have different configuration of final product catalog, in the end, is something that you have to engineer before. And the system needs to support such configuration. We found to be being efficient, okay? And so here we got physical indicators, essentially. Very difficult to go with economical one, because in the end, you have to go back understanding which is the cost of R&D, okay? The example that I made you before about Volkswagen Group, after 7, 8 years, they more or less understand that they were under, okay? So it was easy to understood this one because for car manufacturers, shareholders look which means the profitability of stocks, and they see that Fiat, Stellantis, Ford, and the others goes with more or less 6% per year, and Volkswagen goes with 4.3. Okay. And why? I go back and say, I understand we invest too much in research and development in the wrong way. Okay. So in the end, measuring day by day is very difficult this way. Nonetheless, okay, we have the number of customizable parameters. We will back to this one when we're going to manage production. But if you see a car, okay, there is a number of different, okay, things that you can customize. Steers, the air conditioner, the seats, whatever. And you could have how many variants you have for every single optional. You can add or you have already. Back to service. Now, here, when we speak about performance related with service, we should separate a made-to-stock system with a made-to-order, attempt-to-order, etc. Why? Because there are some performance, availability, stock out persistency that are peculiars of made-to-stock, because are related with warehouse. Okay. After that, there are some other that promptness and punctuality that are typical of made to order. Nonetheless, if we look at made to stock, considering also, okay, the fact that delivery accuracy, okay, incompleteness, promptness, punctuality, all this, okay, could be considered, so all this performance could be considered if the delivery is in charge of you. So maybe, okay, I got it available in the stock, I have to deliver in 2 days. So punctuality is important, accuracy is important, completion is important, and punctuality is important. So in case if delivery is included in a made-to-stock system, we can have also this one reconsidered there, okay? Just to, I already told you that service performance are quite important. Just to show you that this, I say, immaterial performance in the end is very important. This was a survey that has been made within the household appliances sector. We have both suppliers and manufacturers. And here you see a number of different performance. But if you look at the importance, the higher, more important, promptness, punctuality, flexibility, you can see that they can be as important as cost and quality, just to understand. Okay, so service, performance are important. Now, accuracy or precision. Okay, please remember that we are in accuracy means that we are delivering an order, the order line that were required by the client. Accuracy that we are making less mistakes, or we are sending less wrong items with respect to the ones that were expected. So they required 10 different items, okay, few balloon, whatever, and when they receive your track with all the material inside, they compare the expected list with 10 minutes. Okay, when we compare the two lists, they found limited or no mistakes, higher level of accuracy. So the idea is wrong items sent. Some indicators, okay, number of mistakes in the delivery over number of orders managed. Or instead of orders, we can on the number of order lines. Both because maybe some companies or some clients have a large number of order lines with limited number of orders. Some other have, so maybe we have the both indicators. Number of returns due to delivery mistakes. I don't want it, they send it back. So they bring you up and say, please have your track back here. So I will deliver, I will return the wrong item, and then you are going to send another track to have the remaining part that are missing, because that was not complete. Okay, this is typical case. If it's possible, you have a global discount if they accept that goods. In case. This is, in terms of economics, you have the cost of penalty for inaccurate delivery. For, let's say, large producer, usually they go with the percentage over the year. So 98% accuracy on the order lines, it's okay. Some mistakes always happen. But if you go under 98, you pay some million by event and on the single. If you go under 95, okay, other things. But in all the cases, you have an additional cost for managing and accounting activity duplication, because all the documentation has to do again, all the track has to be paid, the drivers, whatever. Okay. Please note that mistakes, delivery mistakes, can be just about packaging, same product with different packages, or in different batches. So the point is that you have batches of 20 units instead of 10 units. But in the end, so this was wrong item sent. But if we go with completeness, other indicators, the point is that this performance evaluates the reduction in the level of service perceived by customer in terms of splitting of order fulfillment. So the point is that you sent the right thing, but not all. Okay? So you need another track coming to your client to deliver the items that are missing. Please note, with accuracy, you send the wrong one. So if you send the wrong one, it means that you need to send another track to complete. So usually low accuracy implies low completeness. Okay? This is the link among the two. And usually this is measured in terms of physical indicators as a number of rows, or the rows fulfilled with the first delivery on the total rows. Okay. Or average number of deliveries for each order. How many tracks you send for delivery. And okay, economic could be the value of order rows fulfilled within the first delivery on the total value of the rows. What is the idea of this indicator? Often our clients ask for a number of items, and usually only the items that have big values are sent immediately. If you have some rows that require some time, but in the end have less value, maybe can be left aside, so we forget to send it, okay? And this is something that is not very welcome by the clients. On the other side, they can say, okay, you asked me for 1 million euros, I send you 99.8, only the SKUs were missing, okay? On the other side, say, okay, if you don't fulfill 100% of the item, I will not pay 1 euro. Okay. It's always a matter of the contract. Yeah. On this one, there is also a cost for fractionation deliveries, number of additional, okay, both in terms of penalties and in terms of additional costs. Availability, inventory, not reliability. What is the idea? We are taking account the phenomenon of stock out. We will find this one many times, but the idea is I, as a client, require something that is not available in the stock. Maybe you can also consider stock out also in a make-to-order model, because I send you, I issue an order, but you tell, I want you to deliver by May, and you respond me, I will be not able to satisfy your order by May, but I will satisfy by July. So the point is that you already finish its capacity till May, so we will be able later. And this is a stock out if you are in a make-to-order model, okay? Now, physical indicators. Number of items in stock out on the total number of items that you have in the warehouse. Number of orders filled on the total orders. Sorry, is different because item in stock out, maybe I have a high pile of this, but the point is which items. You have 10 items in for millions of different pieces. In this one, order is the number of orders. Okay, order lines filled on the total order lines. Calls feeds on calls requested. Okay, very simple. Economic is a little bit different. Okay, again, we will be back to that concept, but there is one way of accounting for the cost of stock out is the cost of the lost margin due to stock out. So the clients come in to ask for one item, you don't have it, he is not willing to wait 2 days for fulfilling the warehouse, and you're losing the client or you're losing that order because it goes to your competitor. In that case, a way of appraising the cost is the loss margin. Okay? But it's not recoverable. But there is always the possibility to have a cost for penalty for delayed delivery. So the point is, I expect you to deliver, and when you sign the contract with the supplier, the opposite with the contract, the buyer, he said, if you are late, every month of delay per item, you will pay €1 of penalty. Okay? There should be a contract clause considering this one, and the concept of backlog will take place. What is the idea of backlog? Is that I'm not able to satisfy immediately the request of the client. I add this order to future demand. So my response is, I'm not able to provide you this item today, but I will provide you in a month. I'm creating a backlog, okay, that I have to respond. So it's going to be summed up on future demand. And backlog usually could be subject to penalties. Cost of loss certification away. Every time there is delay, every time there is a stock out, a problem. Let me make only, sorry. Okay, another slide and we stop. Stock out persistency. What is the idea? The unavailability of the product remains for some period of time. So it's the going out of stock out issue. Physical indicators are average time of delivery of the order delivered, not of the shelf. So the point is how many days on average the clients have to wait because it was not immediately available. Or number of periods in stock out over the total periods. For that item, we were in stock out from December up to May. Okay, so every request that comes into that period, no answer. What is the problem about persistency of stock out? The problem is that when you don't have the product on the shelf available, you have to register the request of that product in order to understand the stock out. If you don't register the demand every time what the client requested, but you just see what is on the shelf, it's apparent that you can say it was not requested because it's not on the shelf, I'm not producing, there is no problem. You get the point? There is the cancellation of the problem. So the idea is if you measure all the time that a client come in to issue an order and you were unable to satisfy and you register, this is exactly what the right way. But sometimes it's happened that if you didn't register this one, you say the product was not on the shelf, and you reduce the impact of such a persistency. Okay? Because in the end, it was not a big issue. Okay? So, the other point is that between potential and actual, if you enter in the supermarket for buying the milk, okay, and you don't find it, the shelf is empty, I say, okay, I will go to another market. But they don't know that you need that milk. And the problem was that it was not available on the shelf. You get the difference? The fact that the good was not available on the shelf, okay, can impose to the client to go in another place to buy it. So the idea, if you are the manager of the supermarket, say, no, I didn't have any request. What is the idea? That nobody complained about the lack of milk. So you didn't register any stock out. Only if there is somebody registering or somebody complaining, you have in mind that you have stock out. Otherwise, you say, Today we didn't have milk, but we didn't have any stock out. Perfect. Stupid, but perfect. Okay? Okay? So, see you on Tuesday, if I'm not mistaken. Okay?